5 minutes comme ça.
Ouais, je préfère.
5 minutes, je veux dire, un truc comme ça. Ouais. Et après, on aura le temps peut-être pour 1 ou 2 questions, pas plus. Ouais, non, voilà, pas plus. Non. Mais si on sera en retard, c'est un peu compliqué parce qu'après, il y a le closing. Du coup, je vais lui dire et après, je vous dis de commencer. On va. D'accord. Ouais. Est-ce qu'on peut mettre le. Donc, attendez aussi. D'accord.
Hi everyone, so it's my great pleasure to be here today. This talk today is about iExec and confidential computing and what you can do by mixing two technologies together, blockchain and confidential computing, and what it can bring to your Dapps. So in this talk, the idea is to introduce you this new paradigm, confidential computing, and we are going to see several use cases. So those use cases are very different. Some of them have been actually implemented by iExec and are running. Some of them are more like kind of perspective or prospective. So that can give you, the idea is really that you can see the great future that is coming with confidential computing. So let's start. Okay, so the outline of the talk is the following. First, I will give you a brief introduction to iExec for those of you that don't know the project yet. Then I will not really explain in details, but just give you an overview of what is trusted compute or confidential computing, or maybe you have heard the name of enclaves, Intel SGX. So these are all the same things, and I'm going to overview this. And then the main point of this talk will be the use cases, and I will try to introduce them gradually so that you understand, what features are available and what they can bring to your Dapps. And finally, there will be a very brief conclusion so that we can go at the party just after this talk. So, at iExec, we are doing decentralized cloud computing. So what does it mean? Basically, we are creating a decentralized marketplace that allows anyone to monetize their applications, their data sets, or their servers. And we are using the Ethereum blockchain to advertise the computing resources. And the key word here is decentralized, so it's a decentralized marketplace, which means that people interact in a peer-to-peer way, and iExec as a company, we are delivering the protocols and the software, of course, but we have no special role in this marketplace. There is no central authority. So that's one thing. The second thing with iExec is that we provide an actual solution for doing off-chain computing. So off-chain computing, that's the idea that you will not execute everything on-chain. A part of your Dapps will run on-chain as smart contracts, and another part of your Dapps will run off-chain using, for instance, the iExec infrastructure. And why do we need off-chain computing? To address several issues that exist now with public blockchain: scalability, privacy, and connectivity. You will learn that during this talk. So to give you a brief overview of iExec, the project started in 2016, created by two former research scientists. So my co-founder is Haiwu He, who was at that time professor at the Chinese Academy of Science, and myself, I was at that time a researcher at INRIA. We did our ICO in April 2017, and since then the team has been growing a lot. We are now 25 people. We are based in Lyon. We had a booth at the conference, so probably you have met many of us. I think half of the team is now there in Paris for your to present the project. So since then, we have released 4 versions of iExec, gradually delivering new features, and the last one was delivered in December last year, so a very fresh one, and we have solved many of the issues. At the moment, I think that iExec is probably one of the projects that can really offer off-chain computing plus confidential computing. So trusted execution environment, or T. What is that? This is a hardware solution to provide data privacy and data confidentiality. So think it as a sort of extensions of your CPU that will on demand create an enclave. So an enclave, think it as kind of a bubble or a safety, a safe. It's a sort of encrypted segment of memory, and everything that is delivered to that is transferred to this enclave, the processor will make sure that somehow nobody can access to what is in this enclave. Okay, so this means that even if you are root, even if you are the owner of the machine, the application and the data that are within this enclave are protected against the owner of the machine. So there are several technologies to implement that. One of usually it's the CPU manufacturers that propose such a technology. At the moment, it's pushed by Intel a lot, and the commercial name is Intel SGX. You may have heard about that. Similar technology are also proposed by ARM, by AMD, and so forth. So at iExec, since more than 2 years, we have been quite active in this area. In particular, we contribute to the Ethereum Enterprise Alliance off-chain trusted compute specification that has been released in cooperation with Intel. We are also part of the Confidential Computing Consortium, which gathers many actors in this area, such as Google and Microsoft and so forth. So in terms of what we are doing with enclaves, we provide an SDK, and this SDK gives developers a full end-to-end privacy-preserving off-chain computing solution. So what does it mean? It means that you can ship your application, your input, and your result. They will be always encrypted, and no one will ever have access to that. More than that, the SDK offers you the guarantee that your execution has been correctly that the execution has been correctly executed, meaning that no one can tamper or modify the result of an execution. So that's very important. And more than that, we provide an on-chain attestation that your application has been actually executed within an enclave, and so that no one can claim that this is an enclave if it's not an enclave. So one important thing is that as a developer, you probably do not want to code your application using the low-level SGX library. So to avoid that, we are working in collaboration with several T providers, such as Cone, Photanix, and Graphene. And here the idea, basically the big picture, is that you come with your Docker image that contains your regular application, then some magic happens, and your application is executed as this without any modification in an enclave. Okay, so that's the magic. We are not exactly in that situation. There are limitations due to the SGX technology, but this is what we are trying to achieve. So to understand the rest of the talk, I will give you some information about how iExec works. So the goal the way you execute an application with iExec is what we call a task execution. So the granularity of execution is a task. And basically it works like this. You have the requester. So the requester asks for a task execution. And to execute a task, we must find the providers that will give the resources to execute these tasks. So there are three kinds of providers: the one that provide the application, the one that provide the data set, and the one that provide the servers, the server that has the enclave. And if everything match, then in this case we can seal a deal and record that deal in the blockchain. And then there is a protocol called proof of contribution that will make sure that everything happens correctly. So here, SGX, the trusted execution environment, T, happens at the trust level. So you can say as a requester, okay, I want the trust mechanism for running this application to be provided by SGX. And then the proof of contribution protocol will make sure that eventually the application has been executed within an enclave. And you can get this information on-chain. So the first use case we can have is trusted execution. So trusted execution, this is the proof that the execution went to an end without having been modified by the machines. So with this, you can create trusted oracle. So an oracle, it's a small program that allows to fetch off-chain information and report that the information on-chain within a smart contract. So with trusted execution, you can make sure that no one will be able to provide malicious information. So you can use that to create trusted random generator for gaming, for instance, or price feed for DeFi. So for instance, this morning, there has been a talk with Keiko. Keiko is a market data provider, and together we built a trusted oracle that makes sure that we use, the price feed. For instance, the Bitcoin price in US dollar is a trusted oracle, and so the information you get is the actual information provided by Keiko, and no one has been able to change that information in the meantime. So another thing that you can do is to address the privacy issue. So you know that when you're running on the public blockchain, one of the key issues is that every information is public. So one way to avoid that is to pass all sensitive information off-chain. So how to do that with iExec? That's fairly simple, actually. So we run what we call a secret management service that itself runs within an enclave. And so you can send your secrets to the SMS, and the SMS will manage that for you. Once the governance has been resolved on-chain, so once we know who can access those secrets, then the SMS will deliver that secret to the corresponding enclave. So secret goes from one enclave to another without ever being deciphered. So with that, for instance, you could use a regular Web 2.0 API, like for instance, the one that does payment, think of Stripe or PayPal or whatever, and then use your own credentials, send those credentials to the SMS, and then being able to process like payment on your behalf within an enclave, and your credentials can travel the network without ever being revealed to anyone. Another example of things that we can do is compute on encrypted data. So how to do that with iExec? Well, that's very simple, actually. You encrypt your data, then you can store them on IPFS, so it's a public remote storage, okay? So anyone can access the data, but of course they're encrypted. And the key to decrypt the data are themselves managed by the SMS, okay? So for instance, this is an example we did in collaboration with Intel, and that has been demoed at the RSA conference last year. So you know that typically, medical images are very sensitive information, and you want to make sure that, for instance, if you have your own medical data, no one can have access to this. So we did this demo last year. So we consider the medical data to be sensitive, so they are always encrypted. They can travel the network to some places where there is an IA program, which is called NILearn, that does neuro imaging, diagnostic from Neuro Image. And then as a requester, you get back the result of the diagnostic, but at any time, your data were never revealed to anyone. Another use case that I'm presenting now is that this basically allows for new model for data monetization and ownership. So imagine the situation. You have a program that generates data within an enclave. So if the data is generated within the enclave, it can be generated once, and so it will be unique. And nobody will ever have access to the data, to this data. And more important, no one can copy the data. And the fact that no one can copy the data actually gives this uniqueness of the data or scarcity if you want to have a little more than one unique data. And as you remember, iExec also allows data monetization. So the side effect, or not side effect, but the nice thing with that is that you can actually be an owner of the data and then run this data to someone. So that means that anyone who will access your data for running a particular computation will have to pay you. So this is very interesting for several use cases like gaming or art or this kind of application where you have unique content. So more than that, what you can do is to create a unique content that can be monetized. And so imagine you have this situation where there is a gaming asset. It has been generated for you. This gaming asset allows you to have a unique identity in the game, for instance. It can be an avatar. And you can expose this gaming asset through a non-fungible token. Okay? So this non-fungible token allows your data to be traded between several users. So the cool thing using confidential computing associated with this NFT is that if you transfer the ownership of the data to someone else, then you will actually lose the access to the data you just sold. And this is where we think we can implement really true ownership transfer for data. Okay, so as a conclusion, I hope that I gave you a good overview of what you can do mixing blockchain, public blockchain, and confidential computing. You can read more about iExec following the website, the documentation, and the tutorials. Not all of the use cases that I presented just now can be implemented as this with iExec, but soon we hope that we're going to have everything ready for that. But still, there are many, many use cases that you can build. So I do encourage you to look at the documentation, the tutorials, and everything, to contact the team if there are any questions. And if there is time.
Thank you, Gilles, for your presentation. So we have time for 1 or 2 questions. Okay.
Hi, thank you for the presentation. I'm not sure I got it right the last 2 use cases. So I see that it's the blockchain which provides the uniqueness of the data. Like everyone can see and verify that indeed this, in the last case, the token is unique. In the case with the data, that the accounting, yes, is like the access, the selling of the data is done by blockchain, right?
So the data is generated uniquely if the generator is programmed to do so first and run within an enclave.
Right, but it's the blockchain which provides the proof for that. It's then because the data is then registered or the token is registered on a blockchain, which makes me believe that there is no other token. I can just check it, right?
No, what you register in the blockchain is the ownership of this data. It's not the data itself. So basically, you create some off-chain data. You store the keys within the SMS that allows people to access this data, and then you register this ownership through an NFT token on the blockchain.
Okay, I got it. So then you still have a centralized system which will relay the blockchain transfer of the ownership with sharing the password.
Sorry?
I mean, how do you share the password then?
So yeah, so once you transfer the ownership, then the idea is that you will lose access to the data that was, to the data that was generated before.
Yeah, but which means that there is some centralized custody for the password.
No, because basically what happens is that when you emit orders, so the data here is to be used within an application. So when you allow someone to use your data for a computation, you explicitly do so by emitting some orders. Okay, so you emit an order, and the orders say, okay, basically you can use my data with this application if the computation run within an enclave, and here you can whitelist or blacklist the application. Well, that's another story. But basically, you have to grant people access to the application, and conversely, to the data. Sorry, and conversely, you can also, if you are the owner of the data, you can emit orders so that people cannot use the data. So once the ownership is transferred, then the one who has the ownership who can emit orders, and those orders will grant people access to the data on it. So.
Oh, thanks.
Maybe last question? No? Okay. So thanks again, Gilles, and good luck for iExec.